Let's look at OpenStax College Physics, Chapter 8, Problem 52. A 90-kilogram ice hockey player hits a 0.15-kilogram puck, giving the puck a velocity of 45 meters per second. If both are initially at rest, and if the ice is frictionless, how far does the player recoil in the time it takes the puck to reach the goal 15 meters away? All right, let's write down our knowns and unknowns. So we know that mass of the hockey player is 90.0 kilograms. We know that the mass of the puck is 0.150 kilograms, a lot smaller. We know that after the hockey player strikes the puck, it acquires a V2 final, a final velocity of 45 meters per second. We know that initially, both the hockey player and the puck are at rest. And we also know that the puck will slide a distance x2 of 15 meters until it hits the goal. And also that mu, the coefficient of friction between the puck and the ice, or the skates and the ice, is 0, which means that after the puck is given a velocity, it will glide towards the goal without decelerating. So it will have a constant speed. And the same thing will happen to the hockey player. He will also move at a constant speed while the puck goes towards the goal. All right, so now what we're looking for is the distance the hockey player will glide backwards in the same amount of time that the puck will go towards the goal. All right, so let's draw some things here on our diagram. So we have a positive x direction that I picked to the right in the direction of motion of the puck. I know that the distance from the puck to the goal is, I called it x2, and that's 15 meters. And I want to know the distance that the hockey player will go while the puck travels a distance x2. So I'm looking for this x1. I also know that initially the speed of the hockey player and the speed of the puck are 0. And after the collision, the puck will move with a velocity v2 final towards the goal, and the hockey player will recoil with a velocity v1 final. So it's a classic example of an inelastic collision where initially the system is at rest. So we have the hockey player and the puck at rest, but after the hockey player hits the puck will move towards the goal, the hockey player will move backwards, and will have conservation of momentum. So let's start out by writing initial momentum equals final momentum. And since it's one-dimensional, I don't have to keep the vector symbols. So I have, before the collision, mass of the hockey player, velocity initial of the hockey player, plus mass of the puck, velocity initial of the puck, is equal to mass of the hockey player, velocity hockey player final, plus mass of the puck, velocity of the puck final. And we know that this is 0. Initially, they're both the puck and the hockey player are at rest. So we have 0 equals m1 v1 final plus m2 v2 final. We want to find the velocity of the puck. Sorry, we want to find the velocity of the hockey player. So v1 final is going to be negative m2 v2 final divided by m1. So when we plug in the numbers, we have negative m2, that is 0.150 kilograms, times v2 final, which is 45.0 meters per second, divided by m1, and that was 90.0 kilograms. When we plug in the numbers, we end up with 0.0 0.075 meters per second for the final speed of the hockey player. So now we know that the hockey player and the puck travel the same amount of time, and the puck covers 15 meters in that amount of time. We want to know how far the hockey player will go. So I'll say that the delta t, which is delta t1 or delta t2, is equal to x1 divided by v1 final, and it's also equal to x2 divided by v2 final. So what I'm looking for in here is the x1. So x1 will be x2 times v1 final divided by v2 final. So x1 will be x2, that is 15 meters, times v1 final that we just calculated, and it should be negative, so it's minus 0.075 meters per second, divided by v2 final, which was 45 meters per second. So x1 turns out to be 0.025 meters, or 2.5 centimeters. So while the puck traveled 15 meters, the hockey player only traveled 2.5 centimeters in the opposite direction. So here's the negative sign for that.